revolutionizing the way that you learn. Need math help? Well, come and have your turn. Stress-free learning.
Good will always be the enemy of the great. Boom. Okay, we're about to get started. Today we'll be doing circles in analytical geometry, right? Okay, so basically, let's look at it more in a practical way because I can't explain to you this in words, so we have to see what the shapes look like. So first things first, we have to look at the general formula. What is the general formula for circles in analytical geometry? Okay, let me write the first one, right? This is the first one. So if you have a formula that says x squared plus y squared is equal to r squared. That is the formula, that's the formula of a circle. You should already know that. That's the formula of a circle. You can try it out for yourself to see if it gives you a circle. But that is the formula of a circle, right? What does the circle have though? This circle here is circle at the origin. So the midpoint or the center of the circle will be 0, 0, right? So what if I want to draw a circle that's not a 0, 0, that's off the origin, right? So that's where you get to the second formula where you have x minus a squared plus y minus b squared is equal to r squared, right? So this formula here, this is for a circle that's not at the origin. Okay, how do we prove that this formula can result in a circle at the origin, right? If we put A and B, which are the centers, right? So A, B. A and B is the coordinate of the center, right? A and B, right? So if we want to get this back, this equation back into the equation of a circle at the origin, right? We look at the origin. What's the point in the origin? 0, 0, right? 0, 0. If we put 0 and 0 over there, this equation goes back to x squared plus y squared is equal to r squared, right? That shows that an origin, so the x coordinate of the center is A and the y coordinate is B, right? So these are the two variations of circles that you will see in analytical geometry circles, right? So let's get started. Let's do an example to see what I'm talking about. Okay, so my question for example 1 says, given x squared plus y squared, excuse my y, is equal to 9. Find the coordinates of the center of the circle and the radius. Also, draw the circle, right? This is a simple question. They will not ask you this in the exam. This is the easiest question that can ever exist. Why? Because we know that when it's x squared plus y squared, just those two, we know that the circle is at the origin. So we already know something when we're drawing our circle. We know that it's at the origin, right? So now, how do we find the radius? The radius, we know in the equation says it's r squared. So what does 9 mean? What's 9? 9 is equal to r squared. So if 9 is equal to r squared, let me write it like this. R squared is equal to 9, right? Because that's the formula. The formula said x squared plus y squared is equal to r squared. And I have x squared plus y squared is equal to 9. Right? So how do I find the radius? R then is equal to the square roots on both sides. Square roots on both sides will result in me saying R is equal to 3. 3 what? 3 units. So my radius, I know what my radius is. Do I know what the center of the circle is? Yes, it's the point 0, 0. Right? I'm just writing it to show you that that is a point. Origin is a point. So now what's the last part? I need to draw this. How do I draw this? Okay, let's look at it like this. Right? It says that this circle is at the center. What does it mean? It means that the center of this is 0, 0. Right? What is the radius? The radius is 3. So this circle goes around the origin, right? And then from here to there is 3. And from here to there is 3. From here to there is 3. From here to there. So any point that touches the circle is length 3 because it's a radius, right? So if they ask you what's the coordinates of the line where it crosses the x, what is the x-intercept of the circle? It's equal to 3. It crosses the intercept at 3, negative 3 and positive 3, right? So let's look at the next question, a little bit more trickier or a little harder than this one, right? A little bit more an examinable type question. Okay, so my question for example 2 says, given x squared plus y squared plus 6x minus 2y is equal to 15. Find the radius and draw the circle. Okay, holy moly, look at my equation. That doesn't make sense. I don't see any equation.
This is probably one of the things that you hear a lot, but you should try to like what you're going to study. Like, because if you don't like what you're studying, I'm sorry to tell you, but you are likely going to join the failing crew. Because there are times when things get really tough, and that small little bit of liking of what you're doing gives you that edge to continue to study, to study after 3, you know?
That looks like that in my general formulas. So now what do? Do I cry and leave this question behind? No, because this is an easy question. Why? Why is it an easy question? Because I feel like some of you, it might be difficult just because some of you forgot something that you did maybe in grade 10 or grade 11, right? It's called completing the square. What is completing the square? You're probably moaning saying, oh, that's difficult. No, it is not. Completing the square is straightforward, it's easy. What is it? How exactly do you complete the square? You complete the square by saying, you add half of what's the coefficient of whatever x and y is. Not x squared, whatever x and y is. Right? Why am I doing this? I'm doing this because I want to get this equation in that format there where I can see it like that. Right? So where do I start? I complete the square. Right? And by the way, 15 is not your radius. And if you say root of 15, it is still not your radius. Why? Because I need to complete the square first before I know what the radius is. So let's start by completing the square. Okay, completing the square. So it will be x squared plus y squared plus 6x, right? This is where the completing the square comes into. And then you add half squared. So you add half of the coefficient of x squared. So I add it. I'll always add it. But take into account, I wrote a positive 3 there. Why? Because you take into account the sign before the coefficient of x. So it will be positive 6. Like the next one, let's look at the next one. So I'll write minus 2y, right? Plus, I always add it. Plus half the coefficient of y. What is half of the coefficient of y? It's 1, right? But it's not positive 1, it's negative 1. So you have to write that negative inside this. So it will be negative 1 squared. So if I wrote this as just 1, positive 1, that would have been wrong. You would have given me a wrong answer and I would have been wasting my time by doing the rest of the equation because it would have been wrong, right? So this is equal to 15, right? But what I do on this side, I have to do on that side. Otherwise, this equation is no longer the same equation. So what did I do on this side? I have to do the same. So I add positive 3 squared plus negative 1 squared, right? So I add it first, and I take into account the sign before it. So I have to make sure I use my brackets. Use your brackets. Do not be shy to use your brackets. Otherwise, you get things wrong that you don't need to get wrong, right? So now we are here, right? So now what do? Now let's combine the parts that make sense. So now you see they are squares, right? So let's combine all the parts that have squares in them. So how do we do that? We make it, so we open a big bracket. We open 2 brackets, right? And a plus in between and squares outside is equal to, let's solve what's on this side. So 15 plus 9 minus 1 will give me 25. Yes. So this will be 25. Right? So I have 25 on that side. So let me look back on this side. That's the important side. This side is very important. If you get this wrong, your equation, your answer will be wrong. So I take the x from the x squared, right? I take the x from the x squared, right? And I don't put a sign over there. And then on the other side, I take the y from the y squared. I don't put a sign because I don't know what sign it is. And now I ignore the 6x, right? And I ignore the negative 2y. What I look at is the numbers that I added and squared, right? So instead of writing it over here, I'll write plus 3. Because why? Because inside the bracket it says plus 3. It's not negative 3, it's plus 3. And then on the other side, what's inside the bracket? It's not just 1, it's negative 1. So I write it as negative 1. And when you write this, now it looks something like something you know. It looks like that formula there, right? So what is the value of A? What's this 3 and what's that negative 1? That is your A and your B. And what is your A and B? Your A and B are your coordinates of your center of the circle, right? So what do I have now? Now I have A and B, and I can also find what the radius is because it's the roots of 25. So my center point, excuse me 1 second, coordinates is negative 3 and positive 1. Why? Because when I take it out of this, it's equal to 0. X plus 3 equals to 0. Then I take the 3 onto the other side, right? Because the equation says it's minusing A, right? So whatever is in A has to change sign, right? So when I take it out, so it will be negative 3 and that will be positive 1, right? So now what do I do? Now I have the center. Now I also want to find what R is. What is R? R is the roots of 25, which would be 5. Right? So now what do I do? Now I want to draw the circle. How do I draw the circle when I only have these points? Why? That doesn't make sense. That's a terrible question to ask if you're asking that. Why? Because you can just draw the circle knowing the center, right? Where is the center? Let me go to the center first, then the rest will follow. So the center is at negative 3 and 1. There is negative 3 and 1, right? So my circle now has to revolve around this. It has a radius of 5. So for it to at least look realistic, right? For me, my circle to look realistic, because the distance from here to there is 3. It has to cross the Y for it to make sense. So my circle will be something like that. If I had drawn my circle on this side here of the Y-axis, or on the Y-axis, and that it didn't cross the Y, it wouldn't make sense because my radius is 5. So from here to there is 5. But from here to the Y-axis it's negative 3. So this will be only 3, and then this point will be 2, right? So basically this is your graph, this is your circle, and those are your 3 marks. That will be 5 marks. They will ask you this question. They will ask you this question. So do not say, maybe they won't ask you. They will ask you, and it will be 5 or 6 marks. So be prepared. Okay, so now let's move on to the intersection of circles. Okay, now speaking on intersection of circles, there are a couple of things that you should take note on. Intersection of circles, this will be like your 1 or 2 marks that they'll ask you kind of question, right? Intersection of circles, let's look at a couple of rules. It says that when D, which is the distance between your 2 circles, when D, which is distance again between your 2 circles, is equal to R1 plus R2, is equal to the radius of circle 1 plus radius of circle 2 added together. If those 2 distances are equal, it means that those 2 circles intersect at 1 point. So what am I saying? I'm saying that this is your circle, right? And that's 1 point where they touch, right? The distance between here, that distance is equal to the addition of the radii, which is from here, this is R1, this is R2. R2 is from that center to the end of that circle. From this center to the end of that circle. If those two radii added together form the distance between those 2 circle centers, that means that circle touches in only 1 point. How do I find this? I just use the distance formula, and the coordinates that I use is the 2 center points, right? That's how I find that distance. R1 plus R2 is just the addition of the 2 radii. And then the other way, if you look at, if it says D is greater than R1 plus R2, right? So the distance between the 2 circles is greater than the addition of R1 and R2. What does it mean? It means that the 2 circles do not intersect. Why? Because this is the center, that is the center, and that's the distance between the centers. And this is the radii. The radius from this is R1, from there to there is R2. That's R2, right? So if I add the radius of R1 and R2, there is no way they'll be equal to the distance of D because there's a huge gap over here. So that's how you know that those two circles do not intersect at all, never, finito, okay? So let's look at another option when D is less than R1 plus R2. What does this mean? The distance between the two circles is less than the addition of the two centers. So it means that the two circles intersect at more than 1 point. It means that the two circles intersect at more than 1 point. What does it mean? So the two circles will intersect here and here, right? So let's look at the centers. This is the center of that circle. This is the center of that circle, right? And this is the distance. This is R1, right? And this goes from there to there, right? And this is R2, right? Those are the two radii, right? But the distance between the two circles is still the distance between their centers, right? And if I add my two radii, they are going to be greater than the distance between the two circles. Why? Because I can move this radius so that they touch each other. They'll be further than the D, the length of D, right? So basically, what that means is that the two circles intersect in more than 1 point, right? So these are the couple of rules that you need to know about intersection of circles. Okay, another thing we need to look at is tangents to circles. So let's see tangents. Tangents to circles, right? The radius is perpendicular to a tangent, right? The radius is perpendicular to a tangent. So let me say, for example, here, this is my radius going here, and that is my tangent. My tangent will always be perpendicular to my radius. This angle here will always be 90 degrees. That angle there will always be 90 degrees. Only to my radius, as line coming from the center of my circle, right? So how do I check that, right? If I find the radius, the gradient of my radius, right? I find the gradient of my radius, and then I look for the gradient of my tangent. If I multiply those two gradients, it should give me -1, because that's the rule that says that if two lines are perpendicular to each other, the gradients multiplied to each other will give you -1. Okay, so let's do an example to see this in action, right? So example 1. We are given x squared plus y squared plus 12x minus 6y plus 9 is equal to 0. Now it says calculate the tangent at point -1 and negative and positive 3 plus root 11, right? Right? So that's what we're looking for. We're looking for the tangent. Calculate the tangent equation. Tangent equation. So we're calculating the tangent equation at that point there. That's what we want to calculate. The tangent equation at a specific point on the circle, which is this circle there. So again, if we look at this, we don't know what that is. We have never seen that formula before. But what can we do to it? We can change it so that it's in the order that we have seen it before. So how do we do that? If you should remember, we just spoke about this. We should complete the squares, right? How do you complete the squares? Let's start it again. X squared plus y squared, right? We don't change those. Plus 12x, unchanged, right? Plus, this is the part where we have to do something. Plus, we always add half the squared of the coefficient of x or y. What's the, not x squared, not y squared, no, of just x. So coefficient of x is 12, positive 12. So you have to divide positive 12 divided by 2 gives me 6. Not just 6, positive 6, right? That part is done. So minus 6y. We don't change that part. Now we add half of the coefficient of 6 of y. What is the coefficient of y? It's negative 6. So we halve negative 6. Not just 6, negative 6. So it becomes negative 3 squared, right? Plus 9 is equal to. But remember, we can't change this side and not change what's on that side, because then this equation is not the same as the one above, right? So what we have to do, we have to add the same things we added on this side onto the other side. So what do I mean by that? So I will add 0 plus positive 6 squared plus negative 3 squared, right? So now that's what I have. Now let me solve this, right? Let me draw 2 brackets first. These are my 2 brackets. Squared, there's a plus in between, squared is equal to. What's on the other side, right? On the other side, I have 6 squared plus negative 3 squared, which is 6 squared, which is 36 plus 9, right? 36 plus 9. That's what I have on this side. But I have a constant that's still on this side. So I need to move that constant so that it's on the other side, right? All my constants must be on one side. Not these ones, yeah? These ones, they are squared. Remember, we balance these ones out by moving those on that side. So, only constant that was there that needs to move to the other side is this one here. Most of the time, what's best to do is to move your constant first. Make sure that all your constants are on one side first. So, first thing you should do over here is move the 9 onto the other side. Right? So now, what do I have on the other side? If it becomes negative, if I minus 9 from both sides, it becomes minus 9 on this side. So it will become minus 9 plus 6 squared plus negative 3 squared, which is just 36, because the 9s will cross out. Because this will be a negative 9, that will be a positive 9, and it will cross out, and you just left with 36, right? That's the easy side, right? Now let's look on this side. On this side, that's the important side. So what did we say? We said we put x and then we put y over there, right? We don't put any signs because we don't know what x, the sign in front and the sign over there is at the moment. So now we look at the numbers. We ignore the one with the 12x and we ignore the negative 6y. We look at the numbers that we added and squared, which are those 2 numbers there. So this will be plus 6. Why is it plus 6? Because that's the coefficient of 6. That's the coefficient of half of 12x, right? For the other one, for the y section, what did we say it was? It's negative 3. It's negative 3. So do we write positive 3? No, we take the negative with us. That's why it's very important that you do not forget that negative when you are halving it. So now that we have our equation, we have our equation in a format that we have seen before. We can recognize that we know what this is, right? So now what do we do from here? Let's draw a visual aid, right? So we'll draw a visual aid, let's say somewhere here, right? So our visual aid says that the radius, right? Let's write the radius. R is equal to the root of this, which would be 6. The center is, what is the center coordinate? It's negative 6 and positive 3, right? Negative 6, why? Because the formula says minus A and minus B. So we take the opposite sign of whatever is here. So this would be negative 6 and this would be positive 3. This is our center and this is our radius, right? So if we look at our equation nicely, our 2 values that we just got, negative 6 is this way, right? So it will be negative 6 here and up 3, right? At that coordinate, right? So let's look at our radius. Let's look at our radius. Our radius is 6. And we just said the distance from here to there is 6, right? Because this is negative 6. Right? And this is 3, right? But the distance from here to there is 6. So what does that mean? It means that our graph, our circle would just touch the y-axis at 1 point, right? So when we're drawing our circle, we have to take that into account so that our circle does not look crazy, right? So that is our circle right there. So it goes 3 down, and then another 3 down, and then it goes 6 up, right? So this is our circle, right? We have our circle. Now we're looking for a coordinate at -1. We're looking for the tangent equation at -1 and 3 plus root 12, root 11, sorry. 3 plus root 11 is a number just above 3, so it'll be 3 point something, right? So let's go to -1. -1 would be somewhere here, right? But we're not looking for a negative number, we're looking for a positive number. So it's a number just above, so 3 plus is just a number just above that 3 over there, right? So our tangent should be somewhere here, right? Theoretically, because again, we don't.
Campus Wi-Fi is glorious. I promise you, you won't want to go back home during semester breaks.
Sure, exactly. This is just a representation, but we know that it should be above 3. So let's draw a tangent line, right? A tangent only touches how many points? Only 1 point. So that is my tangent, right? So my tangent, if that's my tangent, what is my radius? Let me draw my radius. Okay, I had to replace my scissors so that it looks more realistic, right? My drawing was a little bit off. So right now, that's what it looks like, right? So what did we just learn a few seconds ago? We learned that the radius, which is how long, which is 6, is perpendicular to the tangent. And all the time, no matter what happens, the radius is perpendicular to the tangent, right? This is the tangent. This is the tangent here. This line there, that is the tangent. So my radius 6 is perpendicular to my tangent. What is my question asking though? It says calculate the equation, the tangent equation at that specific point that I just drew now. So how do I get my equation? I'll need to use the formula y is equal to mx, right? Mx plus c, right? But I don't know a lot of things in this formula, right? I have a coordinate. What coordinate will I use? I'll use that same coordinate that they gave me where the tangent is, right? Because that's the only coordinate I know about that tangent, right? But do I know what m is? No. Do I know what c is? No. So what can I find? I can find what m is using what? Using the rules that I discovered a while back. What rules did I discover? The rule that the rules that I know that can help me here is that the gradient of the radius is inversely negative to the gradient of the tangent. What do I mean by that? What I mean is the gradient of, so m of tangent is equal to the -1 over m radius. So what does it mean? M tangent is equal to -1 over m radius, right? So now what do I do with that information? I don't know what m tangent is, I don't know what radius is, but can I find what the gradient of the radius is? Yes, I can, because I know the coordinate of the radius, the coordinate of the center, I mean. The coordinate of the center is -6 and 3. So I can find, let me find m radius first, which is equal to, what is m radius is equal to? It's going to be, let me start with this, it'll be 3 minus 3 plus roots 11 divided by, start with this, -6, minus becomes +1, right? So what is my radius equal to? My radius will be equal to 5 root 11 over 5. So that is my radius. My radius is root 11 over 5, right? That's my radius. That's my gradient of my radius. That's the gradient of this line here. It's increasing, so it should be positive, right? So that's my gradient for that line there. But what did I just say? I said that m tangent is equal to -1 over m of radius. So what does that mean? It means that m tangent will now be equal to 5 over root 11. Why? Because if I say negative 1 over root 11 over 5, this will go to the top. If I bring this to the top, if I remove the 1 on top, it will reciprocate. So what does that mean? It means that it will just become negative 5 over root 11. Right? This would be the radius of the tangent. Why? Look at the difference between these two. This one is negative and it's inverted. So if you want to check that these two are in fact parallel, are in fact perpendicular, if you multiply these two together, they will give you negative 1. Try it out on your own to see that I'm not telling you some nonsense. Right? So let's carry on from there. Where can we go now? Now, what are we looking for? Let's see, what was our worry over here? We didn't have gradients and we didn't have C, right? Now we have gradients. Now we have gradients. So what can we do? We can substitute into the formula and work out for C. Let me erase the graph.